Let's look at the first one there, the integral from 0 to 2 of x over 4 minus the square root of 4 minus x squared. And once again, at first glance, it doesn't look like anything's wrong with this integral. We're not integrating to infinity. However, we've got to notice here that when x equals 2, that denominator is 0. And so that means that the function is not continuous at 2. So the integral from 0 to 2 of x over the square root of 4 minus x squared dx, I would write that as the limit as b goes to where? Well, the value that is unknown is the 2, so I'm going to get close to 2 from what direction? From the left, because my interval is from 0 to 2. So if I looked at this, I got something going on here. I want to go from 0 to 2. So I'll integrate from 0 to b and push b over to 2 from the left. So I have to figure out this integral. I can write this as x times 4 minus x squared to the minus 1/2 dx. And this is a basic Calc 1 U substitution. I've got the x already there. So in the land of u, this is the integral of 1/2 u to the minus 1/2. Oops, there's a negative there as well. Add 1 to that, you're going to get positive 1/2. Divide by the positive 1/2. So you get minus u to the 1/2. And so we get minus 4 minus x squared to the 1/2 power. Now notice what happened here is we had a negative exponent in the integrand, which is what was causing the 0 in the denominator, which was giving us that discontinuity. But we integrated it out, and now we have a positive power. And so zeros in the numerator are going to be fine. So we're looking at the limit now as b goes to 2 from the left of negative 4 minus x squared from x equals 0 to x equals b. Limit as, whoops, b goes to 2 from the left. So this is to the 1/2 power of negative 4 minus b squared to the 1/2 power minus negative 4 minus 0 squared to the 1/2 power. So as b comes into 2 from the left, let's write this in terms of square roots here, so we're all cool with what's happening here. As b comes into 2 from the left, I'm plugging in numbers a little bit less than 2. That means that the b squared are numbers a little bit less than 4. That means that the square root here is defined. You're taking the square root of smaller and smaller positive numbers. So this is going to go off to 0. And I'll be left with the square root of 4, which is 2. So we would say that the integral from 0 to 2 of x divided by the square root of 4 minus x squared dx converges to 2. Now let's compare that to this example. the integral from 0 to 2 of x over 4 minus x squared. So notice we just took the square root off. Let's see what happens. Well, we've got the same kind of issue we had in the last example. We got a vertical asymptote here at 2. And so we're going to have to investigate this integral by looking at the limit as b goes to 2 from the left of the integral from 0 to b of x divided by 4 minus x squared dx. Right. So once again, we're going from 0 out to some value b, and then pushing that b over to 2 from the left-hand side. So we need to integrate this. I can make use of a u substitution from Calc 1. So I get a minus a half again, integral of, in this case it's going to be 1 over u du. So we get a natural log out of this thing. So I get negative 1/2 natural log, absolute value 4 minus x squared. So now things are going to behave a little differently than they did in the last example, because I got a log in there. So once again, I'm integrating this function from 0 to some value b, and looking as b comes into 2 from the left. Since b is coming into 2 from the left, once again I'm plugging in numbers a little less than 2. That means when I square them I get things a little bit less than 4, which means that this would be positive, so I don't need the absolute values anymore. And I get this. Now, as b sneaks into 2 from the left, what's going to happen? This is going to go to 0 from the right. So once again, I'm plugging in small numbers a little bit less than 2. Those are going to get squared to numbers a little bit less than 4. 4 minus that's going to be something that's close to 0 but positive. And what do I know happens to the natural log? That's going to go to a minus infinity. So here I've got a negative a half times minus infinity. Minus a negative a half, so it'll be plus that. So I'm going to get negative infinity. So that means that this integral, since we get this integral diverges. Oops, negative infinity times negative is actually positive infinity. Okay? So let's take a look graphically at these two functions that we just did, and once again talk about their growth rates there near that vertical asymptote. So the first function we were integrating was x divided by the square root of 4 minus x squared. And the second one, g of x, was x divided by 4 minus x squared. And let's look what's going on here near x equals 2. We'll make that a dotted line here. Okay, so let's zoom in here what's happening. And so hopefully you kind of see this is the same picture we had, well, a similar picture we had when we looked at these other integrals at the beginning of class. We're just kind of turned sideways. Notice that the first curve here, the red curve, it's getting close to that vertical asymptote much faster than the blue curve is. And so that means that while both of these regions are unbounded, they go on forever, the red function here, our original function, closes the gap to the vertical asymptote fast enough for that area to add up to a finite number. On the other hand, the blue function, the one we just did, you notice it is getting closer to the vertical asymptote, but it's taking its time to do so. So in this particular case, the curve doesn't get close to the vertical asymptote fast enough in order for the area to add up to a finite number.